AOPS counting and probability 8.24. 6 green balls and 4 red balls are in a bag. A ball is taken from the bag, its color recorded, then placed back in the bag. A second ball is taken and its color is recorded. A. What is the probability that the two balls are the same color? B. How does your answer to A change if the first ball is not placed back in the bag? So for A, the probability of two balls being the same color. So the probability of it being red, both of it being red, is 4 over 10 times 4 over 10 since there are 4 red balls out of 10. And since you put it back in, that means there's still 4 red balls and 10 total balls after the first draw. So in total, it's 10 over 4 over 25. And the probability of them both being green is 6 over 10 times 6 over 10, which is 9 over 25. So in total, the probability of the two balls being the same color is 4 over 25 plus 9 over 25, which is 13 over 25. And B, how does your answer to A change if the first ball is not placed back in the bag? So then red would be 4 over 10 times 3 over 9 since there are 3 red balls left and there are 9 total balls left, which is 2 over 15. And green would be 6 over 10 times 5 over 9 since there are 5 green balls left out of 9 total balls, which is 1 over 3. So then the probability is 2 over 15 plus 1 over 3, which is 7 over 15. AOPS counting and probability 8.28. My school's Future Mathematicians of America Club has 16 members, 7 boys and 9 girls. A president and a 3-person executive committee are chosen, where the president cannot serve on the committee. What is the probability that the president is the same gender as the majority of the committee? So case 1 is if the president is a boy. So since there are 7 boys, that means there are 6 choose 3 boys for 3 other boys because if the president is a boy, that means there are 6 boys left for the 3-person committee. So there are 6 choose 3 ways for 3 boys, and for the girls, it's 6 choose 2 times 9 ways for 2 boys and 1 girl, since you also need to choose 1 girl. So there are 7 choices since there are 7 choices for the boy president, then the total probability is 7 times 6 choose 3 plus 9 times 6 choose 2, which is 1085. And case 2 is if the president is a girl, so there are 8 choose 3 ways for 3 other girls. If there's 1 girl as the president, there are 8 girls left, and so there are 8 choose 2 times 7 ways for 2 girls and 1 boy, since you also need a boy. And since there are 9 choices for the girl president, that means the total probability is 9 times 8 choose 3 plus 7 times 8 choose 2, which is 2268. So in total, 1085 plus 2268 is 3353 successful ways. So the total possibilities is 16 times 15 choose 3, because there are 16 members that could be president and 15 members that could be part of the 3-person committee. So there's 7,280 ways in total. So 3,353 over 7,280 is equal to 479 over 1,040. AOPS counting and probability 8.33. Wayne and Mario play a game in which they take turns flipping a fair coin. The first one to flip tails wins. Wayne goes first. What is the probability that Wayne wins? So Wayne's probability to start off is 1 over 2 because it's a fair coin. So if you flip tails there's a 1 over 2 chance. And so Mario's probability of getting it on the second total turn, so Mario's first turn, but in total it's the second one, is 1 over 2 times 1 over 2, which is 1 over 4. So if Wayne's probability is p, then Mario's would be p divided by 2, because Mario's has to multiply by 1/2 of Wayne's because he's always after Wayne. So p plus p over 2 is equal to 1, since the total probability is 1. So P is equal to 2 over 3. So the probability of Wayne winning is 2 over 3.